to Buenos Aires and to Argentina, and to thank Herman and Ariel who've been looking after me, and all the other people who've also been looking after me over the last couple of days. I want to talk about my book, which sometimes people expect me to do, so I will. This is the sort of basic thesis of the book, and I want to add on some bits which I have been thinking about more recently that come out of the last chapter of the book. So the basic thesis here is that scientists represent our world into artifactual models. They're man-made, they're not just found, they're man-made. They're typically mathematical, statistical, or diagrammatic. Those small worlds become autonomous working objects, and the working objects is what I want to focus on today, the qualities of working objects, and that those working objects are used in various kinds of knowledge production. There's two main dimensions. One is to inquire into the world inside the model, so the world is represented in the model, and a lot of economics is about inquiry into that small world posed in the model. And a lot of that work is primarily theory development work. It's figuring out the limits of the theories, figuring out the constraints built into the theories. It's figuring out what those theories that we've instantiated tell us about the way we've figured about them. Much more problematically, those small world models are also used by economists to help think about the big world, the world that they are taken to represent, and also sometimes used to, not just to understand that world, but to think about intervening. Now, of course, not all models in economics are what I'm calling small world models. I'm mostly talking about those mathematical models you find in a lot of mainstream, particularly micro, but some macro. So not all models in economics are going to be working objects in the way I suggest. So I'm not talking about great big macro models, which I think of rather like climate science models. They're trying to model everything at once. I'm not talking about econometric models, because by and large, although I will talk about one of them, I'm not talking about models that have an empirical end, a statistical end, which would give you that potential match, which would tell you about the world. So when I'm talking about a technology of objects which help you think about the world you live in, I'm talking about that as a kind of casual empiricism rather than anything strict and definite and well measured as in econometrics. So I'm trying to capture something which I think is not just true of economics, but is true of a number of other disciplines now. I was recently at a meeting of veterinary scientists, animal scientists, and there were people there who said they had a PhD in modelling. And I couldn't figure out what that meant. But in their community, that's what you have. You have a PhD in modelling, and you just happen to be in an animal science. But they've even lost, you don't have a PhD in economic modelling, you have a PhD in modelling. And these are people who have learnt modelling techniques which they take across borders between physics and biology and maybe economics. So I'm talking about that kind of activity, the modelling activity. And I'm particularly interested in this talk in what kind of qualities working objects have. What kind of qualities do models need to have that make them into good working objects that are going to give us this technology of inquiry in sciences. And I'm starting off from a very nice discussion by Lorraine Daston and Peter Gallison about the history of objectivity, but in this case, they're talking about working objects. Working objects can be atlas images, type specimens, or laboratory processes. And I've highlighted the things I think are important. Any manageable and communal representatives of the sector of nature under investigation. Basically, science can't do science if it has just a whole lot of particulars. You need some kind of working objects which have standardized this chunk of nature you're trying to think about. Otherwise, you don't know whether you've just got a one-off particular or whether you've got something that's going to give you some more power. So it's that standardization, and standardization isn't the right word here for us, for me, but it's something about being able to represent at a level of a class, not being So standardization can mean something like the form of maps. Manageable means something we can work with. Communal means it's going to be something that is shared across the community or within a set part of the community. Very typically when we think about economic models, there are shared objects that people are going to argue over and develop and so forth. So what qualities, taking these as a sort of starting point, what qualities make models good working objects for science? They need to be manageable. That means, as far as I can see, is they need to be small enough for you to work with them. One of the reasons that some big macroeconometric models disappeared was because by the time you get to a certain number of equations, they're not manageable in terms of the kinds of ways I want to talk about manageability. So they're manageable, small in relation to the cognitive abilities of the scientists. Their working objects means that they must be objects that you can work with. And I mean something more than Daston and Galison here, because to me that means they've got to be workable. You've got to be able to do something with them. They're not just type specimens of a finch, as Darwin might have had. They're things you can actually manipulate. In order to manipulate them, you've got to have you've got to have resources in them that can be worked with. So they're not just working objects for me, they're workable objects. Okay? They're not just objects I, as a scientist, can work with, they're objects I'm going to do work with. They have to have capacities to reveal. And I want to focus something which I didn't talk about in the book, but something I've been thinking about since, which is the number of dimensions that are in a model that give you the capacity to reveal. So that's another aspect which I think is here. And the final one here is to be justifiable as typical or exemplary, that is, representative in some way. So I'm thinking about this representative power a bit in the way that, for instance, the Daston and Galison type specimens, that's so not just any dead finch, but one that represents the type of finches that you're interested in. So something about these working objects needs to have representative power. Okay, so now most discussions about models talk about representations. Well, something can be a representation of something and have representative qualities at the same time. So I'm not trying to say it's representatives rather than representations. I'm trying to say that our representations may have, in certain cases, a representative quality as well. So I'm wanting to capture the representative quality that makes them into working objects. So particularly the obvious one that one would think of in science are model organisms. That's the fruit fly, the zebrafish, whatever the yeast is that's endemic. Those objects which biologists pick out as being the objects that the organism that's going to represent a particular class of things. Fruit flies for insects, lab mice for mammals, whatever it is, there's always a particular organism that's picked out because it has representative power for other mice, but also possibly for mammals as a class. So the idea with the representatives is you can find a representative, then you can explore the representative, you can explore the fruit fly for its genetic qualities in order to tell you something about something more general, genetics in general. And it's the representative power that gives you that possibility of moving from the specific to the general. So let me talk about these in turn. Now, I get criticised by economists for calling these things small. Actually, don't mind small, but they hate little. I don't know quite little is pejorative, but small seems to be okay. And the point here is that the classic critique of models is that how can they possibly tell you anything about the world? Look how small they are. They don't really have enough content. And look how false they are. They don't represent anything that we think really goes on in the world. So it's a kind of classic problem that they don't represent in a way that is going to be any use for you. And part of that critique is smallness. I think this is kind of an unhelpful place to start with because it tells you what models don't do rather than what models are potentially doing. Right? So if I'm thinking about what models might be like, I want to say that models are not necessarily simple, small, simplistic or toy-like. They might be, right? But they're not necessarily just going to be completely useless because of their size. And I think the way to think about them is to think of them as miniature or compressed worlds. So my idea of a world in the model is not that it's just a small, simple one, but it's being compressed down, a bit like when you cook a sauce and you reduce it down. You know, it's a kind of focused, intense account of something. So I want to explore this a little bit by coming at it sideways, because I think it's very often difficult to get out of this critique problem here. Think maps, well, maps is a kind of a standard thing to think about as a comparison, and I very much like the paper that Diego and, who was it? Diego. And Herman did this, which is a very nice paper on maps. So models as maps. So just read this paper and you get it all. But the point is that, well, as they say, not every detail is given, but you're going to exhibit the relations you can't grasp by eye, and that they're really useful objects that get around the world. They're miniaturized accounts of the world, and you can have bad maps and silly maps and simple maps which don't tell you anything. But of course, most of us who like maps think that they can be really useful, and they're in this miniaturized version of the world. Poetry is a much less obvious thing to compare scientific models with, but I do think it's worth thinking about. Here's another small, potentially very small form, and the reason I like poetry is because it's very formal. A lot of poems have a very particular form and have to be expressed, whatever is expressed has to be expressed according to these very strict forms. So thinking about what models can be, as opposed to this critique, they can be miniature compressed worlds of the kind of descriptions, the kind of things we have in maps and poetry, small enough to be manageable, but spacious enough within their boundaries to actually represent or reveal or give us some insight. And here's one of the examples of maps I often work with when I teach. It's the very famous set of maps of London. It's a social scientist map of London because it's based on a large survey of the poverty of the households in London, street by street. And it also shows two of the big new stations that were built in the mid to late 19th century on the edge of London, King's Cross on the right and St Pancras on the left. Well, one of the things about stations is if you're inside them, it's really difficult to get a handle on where things are on the size. It's actually quite helpful to have a map because then you see the relationship of the parts. But this map reveals a whole lot of things about the social class structure of London because the survey is being turned into a map, and the map reveals a lot of information which you couldn't get from a table or just by going through all the details of the survey, because it's a way of, it's a working object to express lots of information you already have. So maps are like models in that they are small worlds, they're manageable by construction, they omit certain things in order to make it possible to put them into the right scale. Again, they're dependent on purpose. They have abstractions, they denote things in certain ways, and they have sort of simple colour coding to help you figure out. But social science maps give you, they don't tell you something you couldn't have known by any other way, but they certainly reveal it in a way that probably makes it much clearer than if you had to, as it were, read through a table. Here's poetry. These are haikus, Japanese form of poetry, which are very small and extremely strict in their requirements. Extremely strict. About the sort of smallest, strictest form I think there is. So these are early ones in the 1600s. And the point about these is they're really, really, really compressed accounts. My usual version is a sonnet, but I can't get 14 lines on a page. But sonnets express this similarly. You know, you've got 14 lines, the rhyme structure has to be such, the metre has to be such. There's two different forms, they both go back to the 13th or 14th century. If ever there's a formal object, which has to obey certain rules, it's a poem. These kinds of poems. And I had this sort of insight about this smallness in poetry by listening to, we have something called a poet laureate in Britain, who's the official poet and has to write official poems on official occasions. But she was being interviewed, and the interviewer said, you know, you write very small poems. How do you manage to express anything? They're so small. And she said, this is a really strange way of thinking. Even in a very small poem, you can express, there's a lot of space within a small poem. If you are articulate enough, you can express lots of things even in a small form. So smallness doesn't mean smallness, meanness, it means space within which you can articulate something. And for my purposes, they're really neat because they have this very formal rule-like structure, just like a mathematical model. I hope you're not completely offended by this comparison, but here, okay, so small worlds doesn't mean that they're mean, useless, silly. They can be expressive and they have articulate space inside them. Okay, the second point, second thing we need to get these objects to be working objects is workability. To have workability, you need resources for investigation. It needs internal resources to make them into objects of investigation, means of inquiry. And what I'm arguing here, which I think is something which wasn't part of my thinking when I was doing the book, was that workability depends not only the possibility of manipulability, but the possible dimensions which can be manipulated. So thinking about the space inside a model, the size of a model, one of the things to look out for, I think, is the dimensions of the things that can be altered in working with this model. And I want to say that workability is not quite the same as reasoning. So this is where we begin to see the difference between maps and poems and these small world working objects representations. So maps can be revealing, but they're not necessarily going to be workable. Dimensions. Here's a 3D model. It comes from a little children's playground. It's quite charming, but it doesn't move. There's no working resources there. It's just a 3D. So the dimensions is not just the number of dimensions, but also the workability. So three dimensions is better than 2, maybe, for what you want, depending on what you want to do. But it also needs some possibility of these people actually working here. Here's possibly the most famous map in the history of cartography, which some of you may have seen before. It's a map denoting Napoleon's Moscow campaign, and it's a 2-dimensional object, but it expresses 6 dimensions. The big fat line, sandy-coloured line, is the French soldiers setting out for Moscow from Paris, and the black line is the soldiers coming back, or the lack of soldiers coming back, as the soldiers fall prey to disease, cold, I mean, all sorts of things apart from battle. So very few of them actually make it back. So represented on this map, depending exactly on how you count them, is the size of the army and the changes in it, their positions, there's the latitude and longitude, there's the direction of travel, there's the location of dates when these things happen, and there's the weather. Right? So this reveals a huge amount about Napoleon's Moscow campaign. Right? So it's a small object, 2 dimensions on paper, representing 6 dimensions, a revealing object, but not one that you could reason with in a kind of counterfactual way. You could say, well, suppose the weather wasn't that bad, or suppose they'd taken this route. So you could think counterfactually about it, but you can't, as it were, take out bits and plug them in and do things with them. So it has a limited workability in my sort of terminology. Here's a couple of models which are things I think do have workable resources. The one on the left is the famous tableau économique of François Quinet in the 1760s, which is an account of the circular flow between farmers, landowners and manufacturers. And there's numbers on it, and you can use the basic model with different numbers and different flows to explore whether or not this model of the economy, of the circular flow in the economy, what would happen if you put different numbers in. And we know that's what he did because we have the evidence of sets of different numbers in the bottom line, the top line and the bottom line. The one on the right is in some ways similar, but in the same kind of domain. It's a current model that a development economist might actually wouldn't take with him as he went around Africa or wherever it is. He'd get the local carpenters to make this. And the idea is that it represents the river